Good morning and welcome to our update today on NASA's human deep space exploration plans at NASA's Johnson Space Center in Houston. I'm Rachel Kraft. We have a great panel of experts lined up for you today to tell you a little bit about the progress we're making for missions to the moon and beyond. And since we have people watching on the web and social media, we're going to be taking questions through our Facebook live stream and also on Twitter with the hashtag AskNASA. Our panelists today are Ellen Ochoa, Johnson Center Director, Vanessa Weish, Director of Johnson's Exploration, Integration, and Science Directorate, Annette Hasbrook, Assistant Manager for Orion Program Integration, Jenny Devilites, Deputy Manager for the Asin Abort 2 Crew Module, and astronaut Nicole Mann. And with that, we'll start with Ellen.
Thank you. I'll add my good morning and welcome to everybody from Johnson Space Center here. As you can probably see, I'm wearing my shirt from the first Orion flight test, EFT-1, a few years ago, which I always like to wear because it reminds me of the excitement of that day. You know, it was the first time that we had flown a vehicle designed to carry humans that far away from Earth. It went up to 3,600 miles. And it was testing the items that are really most critical for crew survival, including things like the parachute system and the heat shield. And it made headlines around, not only around the country, but around the world. And it's really just a hint of things to come. So today is a good opportunity for us to update you, not just on the progress of Orion, but also on the other exploration activities that we're doing here at Johnson Space Center. And at JSC, we're really in the thick of things. We're working with headquarters to support the development of the Gateway. We work with other centers, with international partners, talk to a variety of commercial partners as we look at the variety of activities that NASA will work with them to carry out in the lunar vicinity, either around or on the moon in the future. And in much the same way that here at JSC, we integrate all the activities of the International Space Station, working with a whole variety of partners, JSC is well positioned for that integration role for the Gateway as well. And we're already well into it, as you'll hear today. In terms of Orion, just to kind of set the stage, we have 2 more flight tests that we will carry out before we actually put crew on board. And so the first one is just about exactly a year away. It's called AA2, and it will test the Ascent Abort system of the Orion spacecraft. It's just a 3-minute test, but it'll be an exciting 3 minutes. And you'll hear today about how our own engineering organization here is really preparing that test for the Orion program and how we're using a lean, kind of streamlined process to go ahead with that test. And then the second flight test, of course, is EM1, Exploration Mission 1, and that will be the first combined flight of the SLS rocket with Orion. So a lot coming forward as we move towards that. And with that, let me introduce our next speaker, and it's Vanessa Weish. As Rachel said, she heads our Exploration, Integration, and Science Directorate here. And that's really the key focal point for our exploration activities at Johnson Space Center.
Great. Thank you, Ellen. And good morning again. I'm excited to be here to talk about what we're doing at JSC to help with NASA supporting the administration's policy to lead exploration with commercial and international partners to enable human expansion across the solar system, beginning with missions to the moon, as Ellen said, followed by missions to Mars. Building on the transportation elements being developed today, the Space Launch System, SLS, and Orion, that you'll hear more from our next panelist, and using the International Space Station as a platform to test technologies in LEO, we're working with commercial industry and our international partners to build and assemble a crew-tended spaceport in orbit around the moon in the 2020s. NASA and its partners will use the Gateway for deep space operations, including missions on the moon with decreasing reliance on Earth. We'll use the lunar orbit as a place to stage where we will actually build up a small crew-tended spaceport that we will then do testing. We will learn about what's going on at the moon. We'll do testing on the moon surface, and then we will build up, do other testing, and move on to Mars. So at JSC, as Ellen mentioned, we're in the thick of things. We're leading the systems engineering and integration, which is overall orchestration of what are the elements that need to be built and designed, and then how do they need to be tested, how do they get put together so that we actually have a spacecraft in orbit that works together. Here at the Johnson Space Center, we work with other NASA centers, as Ellen mentioned, to make this happen, along with headquarters. We've had several wonderful, outstanding opportunities to meet with our international partners and the commercial community to talk about the design. So we've been moving forward with that, looking at which elements are needed. The first element is going to be the power and propulsion element. That element is being led by the Glenn Research Center, and we support them with engineers to help them with development of standards and requirements that will be used by the commercial industry to build that beginning element. It will provide power and propulsion for the entire gateway. It also will serve as a communications relay back to Earth, also to the moon as well, and will provide space-to-space communications between other elements when they come to the gateway. In addition, the habitat systems are currently being designed. Concepts are underway between the commercial industry. We have 5 commercial partners that are part of what we call our Next Step BAA, where they are looking at concepts that they are laying out and saying, these are potential ways that you could build your habitats in space. Of those 5 companies, there are going to be 2 companies that will do ground testing here at the Johnson Space Center. So we're readying ourselves for the hardware to show up so that we will test it. That will happen next summer. Getting ready for that opportunity, we have plans this May where we'll have some human-in-the-loop testings with concepts in what we call our integrated power avionics and software lab, where we will look at how do these systems actually work together. We will do integrated testing between our facilities here and all the other ground systems that will be used across the country. In addition to that, at the Johnson Space Center, we have testing that we're doing currently using the space station, looking at how do you do autonomous operations, what are our next generation life support systems that we'll be using, as well as other advanced technologies. In addition to that, we are also a part of the Mars Study Capability Team. So we are leading the efforts not only for what's going on in the lunar vicinity, but what else is going to be going on at Mars. So we're working together to lay out those plans and bring those forward. Thank you.
Thanks. Well, good morning. I'm here to talk a little bit about Orion and our preparation for EM1 and EM2. As I'm sure many of you know, Orion is NASA and the nation's spacecraft that's going to enable our astronauts, Nicole Mann and her fellow astronauts, to go explore and be part of the multi-decadal exploration that we as NASA and this country and the world want to do. Orion is more than just a crew module. It's a complex set of systems, life support, propulsion, thermal control, and it consists of more than the spacecraft. We have the launch abort system on the top, then you'll see the Orion capsule in the middle, and then it's also an international enterprise, so we have the European service module on the bottom. If I could have the first slide, please. And so it's built on our foundation. You'll see the spacecraft. It looks a lot like the Apollo spacecraft, and that is what the genesis is from. It started with the Apollo spacecraft, but obviously we've built upon that, and we now have the Orion spacecraft. Do we have slides today? Okay. For the next one, if we can show the Exploration Mission 1 crew module, down at the Kennedy Space Center, we're making great progress. That is our production facility, and that's where we're assembling the Exploration 1 mission spacecraft. So it's gone from a shell of a structure with green primer paint over to a complex spacecraft where you can't see the primer. We've put in the systems, we've put in the avionics, we've got the wiring going, you can see the back shells are on it. So when you go down there, it is so inspiring. You're thinking, wow, this is what we are building to let our astronauts explore. It will be an uncrewed test flight. we're currently towards final assembly, and we're awaiting the European service module, which will be arriving later this summer. And the next slide shows a picture of the European service module. It's being assembled in Bremen by the Airbus Corporation, and they are doing a first-time build of this service module, and they are in almost final assembly, integration, and test, and will be bringing that service module, delivering it to the Kennedy Space Center later this summer. And once that arrives, we have a 404-day timeline to bring it from the time we bring it in until we turn it over to the ground systems at Kennedy Space Center for final integration onto the amazing SLS rocket for launch, hopefully at the end of 2019. That is the goal we're keeping toward. We've done an in-depth assessment of that, and likely it will be in early 2020, but we are keeping our pressure on our agency and our folks to try and launch in December of 2019 to make sure that we put our best foot forward and do our best to meet those deadlines. And once we complete the Exploration Mission 1, we're also currently building Exploration Mission 2. So our last slide shows that we have multiple vehicles in flow, and the Exploration Mission 2 spacecraft is currently under assembly at the Michoud Assembly Facility down in Louisiana. So they're building their primary structure, and that's going to be delivered to KSC later this summer to begin its integration. So we have a lot on our plate. We have EM1 and EM2. EM2 will be taking our crew members past the moon, 40,000 miles past the moon, which is further than we've gone in human spaceflight to date. So it's a really exciting time. But before we get there, we're going to test our launch abort system, which is a critical aspect. And with that, I'm going to let Jennifer talk about the AA2 mission.
Okay. All right. Thank you, Annette. So it's a 3-minute flight test, as Ellen mentioned, but it's really the only full-scale system test that we have before we put crew on the vehicle. So definitely critical for making sure that we can get the crew safely away in an emergency. We talked about the launch abort system. That's the piece on top. So for the flight test vehicle for this flight test, that's going to be the same production article that we'll be using for the real Orion vehicle. Underneath that is the crew module, which you see behind us for our flight test. That one is being provided here by NASA as an in-house project. You can see it's the same size, it's the same shape, we have the same mass as the mainline EM1 and EM2 Orion vehicles. We'll also have a separation ring underneath. If you look at the vehicle, you see the service module. We'll have just a ring at the top to replicate that, and that's used to attach the crew module to the booster, and then we'll have a booster that's much shorter than the SLS. We just need it to get us up to our abort condition. That's being built by Orbital ATK, who also provides the solid rocket motors for the launch abort system itself. So for our flight test, launch will be from Cape Canaveral, and it will be on that solid rocket motor. It's similar to a Minotaur first stage, and we get about 500,000 pounds of thrust. It takes about a minute just to reach the abort condition, which is at 31,000 feet, or about 6 miles. And so let's cue the video and talk through what happens next. So when we reach the abort condition, the crew module flight computers send the commands to light the abort motor rocket and command the separation to separate the crew module from the booster. When the abort motor fires, it pulls the crew module away from the booster extremely fast. After 1.1 seconds after abort, we've got greater than 5 F-22 fighter jets on full afterburners in terms of thrust, so that's a lot. After 15 seconds, the crew modules gain more than 2 miles of altitude. At around 43,000 feet, the attitude control motor starts to reorient the system. And then after reorientation is complete, the last separates to free the capsule to descend safely back to Earth. In an actual abort scenario, parachutes would deploy that slow the spacecraft down for a water landing, and then the crew returns safely to land. But for our flight test, we're skipping the parachutes since those are being tested separately. Shortly after the last separation, we have data recorders that eject with another pair every 10 seconds, and that helps us ensure that we can recover our data after the flight. So here at JSC, we are leading the crew module development as well as providing the systems engineering and integration. We're responsible for the design and the development of most of the powered crew module hardware and software. So just like the mainline Orion vehicle, we've got flight computers, we've got batteries, and our vehicle will have over 11 miles of wire. We've got navigations, communication equipment, and over 200 sensors that we use to measure the flight environment. The instrumentation system is being provided by Armstrong Flight Research Center, and then we integrate it here. Our flight software is also developed here at JSC, and that's how we manage all of the sequencing and control during and after the abort. So our powered systems have been tested here at JSC. We've got a facility down the hall. We've been testing them here for about a year. And then the flight components have also been through vibration and thermal testing here on site at JSC. The structure behind me arrived from Langley Research Center at the beginning of March, and we should have everything integrated into it by the end of the summer, and then we'll start our powered testing here. And then we'll use the control center we have back here to perform those powered tests of the vehicle. We also do full team mission simulations because our engineering team actually serves as the operators as well during the mission. And so later this year, we'll send the vehicle, we'll send the computers, we'll send the team all out to Florida, and then we'll work launch integration and also prepare for the actual flight test. One of the other things that Ellen mentioned was lean development, and that's been really one of the goals of this project as well, to look at how we can do things differently, find more efficiencies, and not just for the AA2 flight test, but also look at approaches that we could use to apply overall to human spaceflight system development. So one of the things we focus on is our team culture, which is really critical to establish an environment that allows people to innovate and to do things differently. Our project management and systems engineering activities, we're continuously looking at the right level of rigor and how much detail we put into everything. That's a big place to get cost savings, so we're very diligent about that, trying to figure out how much of the process is the right amount. We also reduce cost and schedule through iterative systems engineering, and so the idea there is to keep building and testing so that what you end up with at the end is the product that you wanted. And by doing that, we actually had 90% of our flight software was complete by the time we got to our critical design review because of all the early integrated testing that we did. And we also used an agile software development process for that. And then the last thing really on lean development to mention today is we do use a novel approach for systems engineering and team communication. So we have a data-centric online collaborative system that the whole team can get to access to. So two things about that. One, we generate a lot less documentation than a lot of projects, and it also helps us move through decisions very quickly at every level of the project. So as I mentioned, our next major milestone is our powered on testing, and then we'll be launching this in about a year. Now I'd like to turn it over to Nicole Mann.
Thank you. So I tell you, this is a really exciting time to be a part of the NASA team. I mean, I'm sure you can sense the excitement. As Annette mentioned, we are sending humans further into deep space than we have ever done before. And really, to be a part of this team as an astronaut, we're involved early in the development of these spacecraft. I've had a chance to see a lot of the flight hardware in Europe and around the United States. And one thing that really surprises me is that this is really America's spacecraft. As you go around the country and you see some of the companies that are building components on this vehicle, yes, we have large companies out there, but we also have a lot of small companies. There's folks in small towns all throughout the United States that are building a valve or a seal or an instrument or something that is going to be critical to the success of this mission. And so it's really exciting to see the American people and everybody come together in support of this mission. We get to see a lot of that flight hardware, and we're involved in all of the testing of the hardware now. So on a daily basis, you have astronauts that are in spacesuits, that are in the mock-up of Orion, that are looking at the cockpit and the displays and the hand controllers. In fact, this afternoon, I'll be doing an evaluation on some of the hand controllers in Orion. So this is a real flight hardware that is going to be launching soon. And that's a really exciting idea, I think, for all of America, really for all of the world. And here specifically at NASA, at Johnson Space Center, there's a huge team of folks. We work with the engineers, we work with the program managers on a daily basis to help make sure that we are doing things the right way, that we're going to be successful in our mission, and that we're going to keep the crew safe. So it's going to be a privilege one day to fly on Orion, and on behalf of the astronaut office, we are looking forward to flying into deep space.
Great. Okay, thank you. We have some time for questions, and a reminder, if you're watching online, that you can get those to us either through our Facebook stream, our Facebook live stream, or on Twitter with the hashtag AskNASA. So we'll go ahead and start here in the room, and I think that if you wouldn't mind stating your name, affiliation, and to whom you're addressing your question, that would help.
Thank you. I'm Mark Carreau with Aviation Week and Space Technology. I'm going to go back to the beginning of the presentations, and probably I'm asking for a little clarification on Johnson's role going forward with the Deep Space Gateway. Will Johnson, in a sense, be the integration manager for all of the elements? If I understood that correctly, it's either shared with headquarters or it's been designated that Johnson will do that. And then additionally, will you need a contractor separately? I'm thinking back to the way the space station was developed in its final stages. Thank you.
So I'll start out, and if Vanessa wants to add anything. So I will just say that right now at headquarters, Human Exploration and Ops, HEO, they haven't formally designated roles yet or formally come up with an entire acquisition strategy, but that's actually part of what we're working on right now. And we do have our folks right now who are leading the systems integration and engineering. So our people are absolutely involved. But the actual formal designation of roles and acquisition strategies is yet to come.
Yeah.
Anything else?
Yeah, and the only thing is that we're still in formulation, as Ellen mentioned, so we're still coming up with concepts and design, so it hasn't been officially brought forth as a something to be blessed yet. So.
Okay, we'll take a question from social media.
Derek on Twitter asks a really great question. Why the focus on the moon? What are we hoping to learn by going back?
Over here, it was from...
Yes. So there's reasons for going to the moon. There are scientific reasons for going, then also for us in terms of engineering, learning, and being able to be prepared to go further into the solar system. So scientific reasons, we have small companies, there are lots of people that are interested in doing prospecting. What are the resources that are available on the moon? Could we potentially have some minerals and things that we could bring back and actually, use for economic purposes, and then scientific discovery. So one of the things that I didn't mention is that the Science Mission Directorate, they're going to be kicking off what we call an announcement of opportunity. We have some samples brought back from Apollo, and they're going to kick off an announcement of opportunity for people to evaluate some samples that were not analyzed previously, because we now have new technologies that we can learn different things from. And then we will begin to do more robotic missions to the moon as a part of the Science Mission Directorate's need to understand more about what's going on at the moon, the surface of the moon. And then with the Gateway, we will now have the comm systems that will be able to allow us to do investigations on the far side of the moon. So we will learn about things that we've never even known about before. So those are the scientific reasons.
And I'll just mention also that actually for a few years, we've been really planning to spend the decade of the 2020s in the lunar vicinity anyway, because we believe there's a lot we need to test and learn before we actually head to Mars. So as we do spend time around the moon and on the moon, a lot of what we are thinking about is what is it that we need to accomplish there in order to move on to Mars after that.
Okay, we'll take another one here.
Eric Berger, Ars Technica. Can you talk about the AA2 test and kind of the main engineering questions you're looking to address? Because I know you've done the paddleboard test already. Are there major engineering questions that you hope to answer? Or do you think you have it pretty well wired and you're just trying to validate your models and the systems that you've developed? Thank you.
From our perspective, to be AA2 is there to validate the models and make sure the sequence of the various motors work effectively, because that is our, I call it the safety, not the safety valve, but that's one of the prime safety features for the crew, and that's what will help make them confident to get on that vehicle and launch into space. So talking to Brian Duffy over the past year, he was former commander on the shuttle, and he said he would get on that spacecraft today because of that launch abort system. So it's a validation of the motors and the sequencing of the system from my perspective. Jenny?
Sure. So Passport 1, we had a prototype launch abort system, and the one that we're flying is actually the real production test article. So it's important to test the actual thing that's going to go on top of the crew module on the SLS. So it's the production last. The separation mechanisms, pyro, all of that's production, so we're trying to test all the production quality that we can. The guidance, navigation, and control algorithms are also the same that are going to fly on the mainline vehicle. So those are kind of the articles under test, but in addition, it's so heavily instrumented so that we can go back and update all the models. We're only doing one abort condition out of all the ones you could choose, and so it's really important we get all of that data so that we can go create the right simulations and models so we can analyze all of the other flight test conditions that we're not testing.
Okay, we'll take another from social media.
Awesome. So we have a question from Angie Lynn on Facebook, and she is wondering how many people will go there aboard Orion, and about how long will they stay?
So, good question. The Orion is designed for 4 crew members and a mission length of 21 days. That's our baseline for Exploration Mission 2. So that will be the plan, and they will do what they call a free lunar return. So when we do our orbit insertion, they'll do a free lunar return orbit around the moon and then come back.
Okay, Philip.
Hi, Philip Sloss with NASA Spaceflight.com. Just to follow Eric's question about the abort condition for this test, are you targeting a high dynamic pressure, that parameter, some other conditions, or is it just like a high dynamic pressure for this test?
It is a high dynamic pressure, but it's a whole set of abort conditions. So there's a Mach speed, there's a dynamic pressure, there's an angle of attack, so there's a whole box associated with the specific abort condition.
Thanks.
Okay, we'll take another in the room here, Robert.
Hi, Robert Perlman with collectspace.com. Also, in regards to AA2, what were the driving factors that the vehicle was going to be integrated here as opposed to Michoud or the ONC? And was there, I think I remember that originally this test was going to be performed with the EFT-1 capsule. What drove the decision to build a new boilerplate for this mission?
The driving factors, when you say here versus Michoud, the crew and service module test article was being assembled here by our team, and also at Langley, so they actually built it. We're bringing it here to instrument it out, and then we're taking it to KSC, of course, and they will be involved. We'll be stacking it on the launch abort system and then rolling it out to the pad. From the EFT versus building a new test article actually was a cost savings to build the test article device using EFT because we are using the Exploration Flight Test Vehicle for some of the components and further analysis. So we actually did save money in terms of not having to build additional hardware for testing and be able to pull parts off of EFT-1, which we have been doing.
I would say there's one other advantage. So our prime contractor is Lockheed, a great partner for us. And given these 2 flight tests coming up, this allowed Lockheed to focus on, EM1. And it also gave our engineers some great hands-on work here. And of course, we're always trying to understand what is that great mix between what we have the contractors do and what our civil servants do. And we want to make sure our civil servants have enough contact with actual flight hardware that they understand what it takes to do that and they can be smart buyers in the future.
Moon. And maybe you can use this to talk a little bit about, are the astronauts that are going to do these missions already selected, or do you intend to select more before then?
I believe the astronauts have already been selected that will be flying these missions. I hope Nicole does, but she may be flying before we put an astronaut on EM2, which I also hope for her sake. But I think, astronaut selections occur every couple of years, so I think we have the cadre that will be flying on the first human exploration mission, and we'll continue to select more to fly the future ones into the future. Nicole, anything?
Right, so we have an assigned crew specifically for the EM2 mission, but certainly folks that are in the office will be flying on Orion. It'll probably be a combination of veterans, folks that have flown before, and maybe some new folks that haven't even been selected yet.
Hi, Mark Harris with Air and Space. It's a question for Nicole. Is there any collaboration with the Commercial Crew Program? And just talk me through the sort of development process that you're involved with and how that differs or is similar with the Commercial Crew.
Sure, it's really interesting from a testing perspective. The astronaut corps is involved with a lot of this human-in-the-loop testing for Orion, for SpaceX, and for Starliner. And so it's nice to be able to draw on some of those experiences. Of course, there's some proprietary data. You can't necessarily share the information that's coming across, but from an experience and an operational perspective, it gives you that kind of breadth of knowledge, and you're able to apply that in your kind of evaluations of these new vehicles.
Okay, and I think we have a question on the phone. We'll take that, and then we'll go back to another one from social media. Okay, let's try the social media question, and then we'll check the phone again.
So Robin on Twitter is asking if the Saturn V will be used again. So maybe you can use that to explain the difference between SLS and Saturn V and other rockets we're using.
We will not be using the Saturn V. We're using what we call the Block 1 rocket. It's built by Boeing and led out of the Marshall Space Flight Center. In terms of the differences, the Block 1 is taller than the Saturn V, and it has more thrust. I'm not sure the specifics of that, but we could get that information for you. I don't have the specific details. Ellen, do you have it? Yeah, we can certainly provide that.
Yeah. Okay. We got a question in the back there.
Good morning, Ryan Korsgaard from Channel 2 here in Houston. Probably for Dr. Ochoa, if you could help me in non-NASA speak, explain to our neighbors the important role that JSC is playing in Orion and going back to the moon and beyond. Sometimes I have a hard time explaining to people that role if they don't live in the NASA world.
Well, sure. Well, you know, JSC has really been the lead center for our whole history in terms of the design, development, and test of human spacecraft, as well as planning, training, and flying for missions. And, you know, really, that's the role that we have for Orion as well. Now, of course, we have our partner, Lockheed Martin, who's our prime contractor. And again, throughout our history, we've always worked with companies like that. But we're responsible. We have the program management here, and then we also have, you know, the engineering, we have the flight crew, we have safety, human health and performance, which is another prime role we play for the agency. So we have all of those skills here together at Johnson Space Center. Now, again, that's not to say we don't work with other centers, and one of the things we didn't, I don't think, mention about AA2 is the module is going to Ohio for a few weeks this summer for some testing out at Plumbrook, which is operated by Glenn Research Center. You know, the boilerplate that came here was developed at Langley, so we certainly work with other centers, but we do play that lead role for the agency. And as I mentioned, we have also always played this integration role where, you know, there's parts and different kinds of partners all over that will be part of our exploration campaign. And the role that we have for ISS, where we integrate all those partners, you know, we're well positioned to have that role in the future as well because of our expertise in having done that really throughout our history.
And I'd like to add
for the question on the, go ahead.
Sorry, from the human's perspective, sometimes we forget living here in Houston, but all the active astronauts live in Houston. This is our home. The Flight Operations Directorate is part of Johnson Space Center, and that's where we plan, train, and fly our astronauts. So not only is all of our training done here, but mission control is here as well. So all of these missions will be controlled out of MCC here at JSC.
Okay, can we check for the question on the phone again? And if not, we'll take a question in the front here. Okay, we'll go here in the front row.
Good morning. Sophia Sanchez, Cosmic Chicago with Chicago Now. I had a question for Nicole. You spoke a little bit about visiting different companies that were working on hardware for Orion. Can you speak a little about any training or testing you've done on any hardware that was really unique to Orion, or even training in the vehicle itself?
Absolutely, we're involved in training, as I mentioned, on a daily basis. So here in this building, actually in one of the other bays, we have a mock-up for Orion. And right now we're doing a lot of the testing where I would be in a suit and with 4 crew members, we're strapped into Orion. And we have a smoke machine, and they set off smoke, and they close the hatch. And we're looking at, can we get out of this vehicle? How are we going to unstrap? How is the flow of us getting out? What's the timing it's going to take for us? Where do I realize, oh, I got interference, I got hung up on something that we didn't think about? So it's a lot of that testing that's done there. Some of the contingency testing as well. Just last week, I was in the module and we were simulating that there was a problem with the side hatch and we needed to get out the docking hatch. So the engineers had developed a ladder that would come down, and then we would have to throw the rafts out and then climb out of the top of the vehicle. And so you can put all that in a very detailed plan, and the engineers do a great job of developing that. But putting it all together and then doing the human in the loop testing and finding those things that you didn't think about because you have humans involved in this expedition is critical in the early development of this program.
Okay.
So we have a comment on Facebook asking, around the moon, do you need to worry about protecting people and hardware from radiation?
Yes. Yes,
Hardware and people.
Yeah, hardware and people from radiation. And so we are at the Johnson Space Center and with some other centers as well, looking at ways to protect the crew. There's innovative ways to do it. There was an idea the other day of actually having a suit that they would wear that would protect them from radiation. There's pharmacological ways of protecting them from radiation. So yes, and we are definitely studying that. We have a program here at the Johnson Space Center called the Human Research Program, and that's one of their risks that they're trying to mitigate before we go out to deep space.
And we appreciate all that work.
All right, we have time for a couple more probably. Do we want to take one from social media?
Yeah, another really good one is, how does all of this work benefit us back here on Earth?
Well, you know, I think NASA's work and exploration benefits people back on Earth in a variety of different ways. Part of it is we're a global leader, and we are including international partners in our exploration campaign in the same way that we have included them in the International Space Station program. And NASA is the one that coordinates all that, so that's a part of it. Part of it will be the science that we bring back, so expanding scientific knowledge, and you know, who knows what new discoveries will come from that, and I think that's an exciting part of what can be accomplished around the moon. As was mentioned, there are suppliers that participate in the building of Orion and SLS, I think in 49 of the 50 states when you look at both of those. And so we have a number of companies, including many small companies, that have the capability of producing aerospace-grade parts, you know, that we need, but that can also be used in other industries. And we're one of, you know, those customers that keep these companies going. So that's another way of doing it. And then, you know, to me, one of the most important things is continuing, you know, the inspiration and pride that people in this country have for our space program. And that was what was so exciting about EFT1, to really see that coming forward. And we really look forward to being that leader and continuing to move out in exploration farther than we've ever had people go before, and learning so much. And that's a big part of what we bring as well.
Okay, we probably have time for one more in the room if there are any last ones, or maybe one more from social media.
Yeah, this one's pretty specific, but someone on Facebook is asking if there is a height limit for riding in the Orion vehicle.
I don't believe so. I mean, it's rated for what they call 95% male to 5th% female, so that encompasses a broad band. I shouldn't say I don't think so. I'm sure there is a specific height limit. I don't know what the foot inches is, but it does, the capability is there to encompass a broad spectrum of the human population.
Okay, and we'll try one more time to get the question on the phone in. Tom Risen with Aerospace America. Go ahead, Tom, if you can ask your question. Okay. Haley, any more from social media?
Sonia is asking, have you considered potential landing locations yet for lunar missions?
Landing locations.
Have you?
considered?
You mean
well,
on the moon or
on the moon or here?
On the moon.
Oh, okay. Yeah. Okay. So right now we are have orbiters that are mapping the lunar surface, and so we're looking at where the interesting places to go. So the scientific community is coming together to say, should we do it at the equator? There's some that want to do it at the poles. So that has not been determined yet, but yes.
Okay. Well, with that, we'll go ahead and wrap up. I'd like to thank everyone here for joining us today, especially to our experts who joined us. And if you'd like to learn more about what NASA's doing to enable human deep space exploration, including missions to the moon and beyond, you can check that out at www.nasa.gov/moon.